Folks migrating from another programming language into Python often look for a familiar switch case statement, which Python does not have. Python does have a match case statement, but it's not the same thing as switch case, and usually when you're looking for switch case, I wouldn't recommend using match case. Python's match statement is for structural pattern matching, which sounds complicated because it is a bit complicated. The match statement has a different way of parsing expressions within its case statements that's kind of an extension of the way that Python parses code in general. And again, that sounds complex because it is. I'll cover the full power of match case another time, but let's quickly look at a few examples that demonstrate the power of match case. Python's match statement can be used to match an iterable based on the number of items it contains, 1, 2, or 3 items, for example. The match statement can also match an iterable based on its actual values. Here, we're matching the first value as being move, and the second one as being either up, down, left, or right, or we're matching the first value as being turn. The match statement can also match a dictionary based on the keys that it contains. Here we're matching a dictionary with the key of type, the key of error, or something else. We can also match a dictionary that has specific keys and specific values. Here we're looking for a type of circle, for example. The match statement can also match an object based on its type. It can also match objects based on the presence of certain attributes or specific attributes having specific values. For example, this match case statement will match the point 0, 0 as at the origin, but 0, 1 as on the y-axis at position 1. And the various forms of structural pattern matching can also be deeply nested. Here we're using a match case statement with Python's AST module to parse Python code. This match case statement is matching an assign node, which has a call node within it, and that call node is calling the sorted function, while grabbing the name of the first argument passed to sorted and grabbing the name of the variable that we're assigning to. That's a pretty complex match case statement. The match statement was designed to handle some pretty sophisticated pattern matching. It really shines when implementing parsers like this. Match is not designed to be an equivalent to switch. But why should you not use match as an equivalent to the switch statement? Well, if-elif blocks are pretty readable. Compare this match case block to this if-elif block. I don't find the match block all that much easier to understand than the if block. Also, unlike match case, the if statement doesn't require an extra level of indentation, and everyone probably understands this code. Not everyone necessarily understands this code. It is nice to avoid long if-elif statements, but replacing them with match case doesn't help much. Sometimes you can replace long if statements with dictionaries. Here's some code that converts HTTP status codes to their descriptions. Note that we're essentially converting our input values to our output values. Each valid input value maps to a possible output value. Python has a data structure for mapping data just like this. It's called a dictionary. Here's the same code that uses a dictionary instead of a long if-elif chain. I find this much more readable. I like that we've moved our key value mappings into a data structure. The code from before looked like a lot of logic, but it was really data disguised as logic. The dictionary makes it clearer that this bit of code is data heavy, but not actually very logic heavy. Most Python programmers are not very familiar with match case. It's not used very often, and when it is used, it's typically used for pattern matching, not for matching a single value. The next time you find yourself tempted to use match case, ask yourself whether a dictionary might be better instead.